All right, hello everyone. Welcome back. Hope your break was restful and relaxing. I'm sure you all are probably looking forward to the next break that we've got coming up here after we get through this week and then finals, of course. We are going to do an exam. Excuse me. We are going to do an exam review session today, but before we do that, I just want to make sure everybody knows where we're at in the class, knows what's left. There's not a whole lot left, getting very close to the end. There's one more assignment that is due this week in your lab section, but there's no studio, so you don't have to worry about sticking around. You can turn in your assignment and take off if you want to. If you want to stick around, the TA will be there to help answer any questions you have about exam stuff. I'll probably be around as well. Then the exam itself is going to be this Thursday at 6:30. It's an evening exam, just like all of the other ones are. We'll talk a little bit more about that in a second, but then I just want to make it clear that we are going to have that exam graded and returned to you probably by Saturday, so that you will be able to see what your score is on exam 3. You'll know what all of your scores are by that point, and can make the decision to take the final, which is the following Monday, the 9th. And the final exam is taking place right here in this room. Everybody takes the final in this room at 3:30, unless you have accommodations, in which case you'll be hearing from us about what you need to do for that. I just want to make sure that everybody is clear, right? That yes, you will be getting your exam 3 grades back in time to make a decision about whether or not to take the final. No, you don't have to tell me whether you want to take the final or not. You just have to show up. You don't want to take the final, you don't have to tell me that either. You just don't have to show up. It's totally your call, totally your decision to use the drop on the final exam or not. Before I shift gears and talk about exam 3, which is our main topic for today, I just want to take a moment and see if anybody has any questions about the timeline, the schedule for the last week or so of class, including the final exam. Yes?
So from the Saturday, Sunday, Monday, will you be able to, let's say you have regrade requests, are you going to be looking at those over the weekend?
Yeah, regrade requests will open as soon as the grades are back, so I absolutely will be taking a look at those, and we'll get them back by Monday as well. Yep, absolutely, all that stuff will happen. Yeah, not super relevant, but this is not like my idea of a great time either to have to do all this. This is my choice. I've asked the university to please push this exam back for a while now. There's bureaucracy involved, there's logistics involved. So not my idea of a great time either. I'm not super thrilled by the super scrunch schedule, but we will get it done. We'll get through it together as reasonably as we can. Any other questions about the schedule before we hop into exam 3 stuff? I'll make sure everybody knows what's coming up. All right, let's chat about exam 3 then. That's, of course, what our main focus is for today. For a lot of you, this will hopefully be your last computer science exam for this class, right? If you choose to take the drop on the final exam. This is going to cover the materials for modules 7, 8, and 9. We'll talk about what those cover in just a second, but I just want to point out that everything else as far as logistics is just the same as the prior exams. Their rooms are down here, so you'll go to the same exam room that you've gone for past exams. That has not changed. You can bring a sheet of paper with you with notes on it, front and back, like you have for past exams. That has not changed. All of that is 100% the same. And just like for past exams, you also have study materials available in the form of the practice quiz and the coding repository on Canvas. So hopefully you have taken a look at the practice quiz and the coding repository before today, although we're going to take a look at some of that stuff here in just a few moments, just to kind of reiterate what is going to be on this exam. So it's covering everything from 7, 8, and 9. 7 is what we, when we started talking about objects, we started talking about classes. So what that means for this exam is that the word static is not going to appear anywhere. And I don't want you to write the word static anywhere either. The one exception to that is there might be a main method on there, which requires the word static. But other than that one exception, the word static is not going to show up. You shouldn't write the word static either. We are dealing very, very much with non-static things. which requires creating objects and using instances of objects. That's probably what we're going to be talking about a lot today, I would imagine. Module 8 is when we discuss inheritance. So this idea of reusing code across classes, the relationship between the subclass or the base class and the class that is doing the inheriting, right? The derived class. There's an is-a relationship, and we saw that in class with a few different examples, such as saying a square is a rectangle, or a checking account is a type of bank account, right? Those are all examples of using that is-a relationship to specify inheritance. And when you use inheritance, you're grabbing everything, all the instance variables, all the methods, but there are ways that you can kind of tweak what's available to you. And then the last module that we covered before break was module 9 that dealt with abstract data types in the form of primarily lists and maps. Those are the big two that you should expect to see on the exam. We also talked a bit about equality as well. So you can expect to see that concept appear on the exam too. Otherwise, I think that is about all I have as far as my spiel goes about the exam. At this point in time, I would love to do some coding practice or just answer questions that you all have. I do have some ideas of problems that I would like to do if nobody else has any suggestions, but I'm definitely going to start by opening up the floor and seeing if anybody has any specific questions or specific problems that they would like me to tackle. Yes? Code writing car? The car problem? Sure. Let me find it real quick. Here it is. All right, question number 4. Yeah, awesome. So this deals, I would say this material is all in Module 7 land. There's no inheritance going on here. And you can tell that because the word extends isn't showing up, right? So that's a very big clue. If you don't see the word extends here, then you don't need to worry about inheritance. Not at the moment anyway. So no inheritance going on here. We're just talking about how to create and use a car class. And so what are the two main things I expect to find in a class? There's two main categories of things. Let me see. Variables and methods. Instance variables and methods. And we talked about the relationships that those things have as well. Specifically, if you see this expression show up on the exam, has a, right? I hope that's the bright flashing lights going off in your brain saying, oh, these are about to be some instance variables coming my way, right? The has a relationship signifies that whatever the car has is going to become instance variables. So there are 4 of them listed here, and our first task is to figure out how to declare these instance variables. The first one is called the odometer. How many miles have been driven? So what type would we use to represent this? Probably a double, miles driven, or if you wanted to call it odometer, you could, right? I think miles driven is a little bit more explanatory, but potato, potato. What am I missing here? Private. All instance variables should be marked private. Is the computer going to complain? No, but I will. I promise you I will. If you don't mark your instance variables private. That is absolutely required. We talked in class about why that is the case. I hope that message got through to you, and you mark all of your instance variables private on the exam as well. So we've taken care of the first one, but there's a few more to deal with. Fuel efficiency, typically given as miles per gallon. All right, that sounds like another double to me. There's a fuel tank, which can hold some amount of fuel in gallons. I think double is still good for this one, honestly. And then the current amount of fuel. So this is like the maximum amount of fuel. The fuel tank is supposed to represent, how big the tank is. My car has, 12 gallons. But that's not how much gas is actually in the car, right? So maybe we should rephrase this as max fuel, size of fuel tank, right? And then we have another one for the current amount of fuel. All 4 of these instance variables that I created came from this right here. There were 4 items listed, and I have 4 instance variables. That's not a coincidence. That is That is exactly what I would expect to happen. Are there any questions about these instance variables that I created, how I created them? All right, let's keep going. The next thing that we are asked to do is to create the constructor. What does the constructor do again? It assigns values to the instance variables. That's how it achieves its task. What does the constructor do for us? When I call the constructor, what happens? Creates an instance of an object, an instance of a class. That's exactly right. The role of the constructor is to create an instance. So I'm telling it to create a specific car. And how does it do that? Well, it does that by setting these instance variables. And so we have to make a choice for each instance variable. Where is that value going to come from when I create this car? Right? Where is the value going to come from? The idea is that either I can say that the user has to pass in that value as a parameter to my constructor, or if it's a constant value, i.e. I just know what the value is going to be, then I can just say that. I don't have to use a parameter to express that. I can just state that constant value in the constructor. But regardless, I have to make sure that I've got 4 assignments, one for each of these 4 instance variables. So if we think about the number of miles driven, right? Our question is, do we need a parameter for this or not? And I would argue that we don't. When a new car is first created, I know how many miles it has driven. It has driven 0 miles. It's brand new. Just came off, right? So for miles driven, I would say that's just going to be set to 0. All new cars are going to start with 0 miles on the odometer. For the miles per gallon, that changes, right, from car to car. So a value that changes from car to car, you know, my Honda Fit is going to get better gas mileage than your Toyota Highlander or whatever you're driving around. So that's going to vary from car to car. To me, that indicates that that needs to be a parameter. So I'll take in a double for miles per gallon and use that to set the miles per gallon instance variable. Let's talk about the fuel tank, the maximum amount of fuel. Should that be a parameter, or should I just set that to be some constant value? Does anybody have any opinions? Yeah.
I think that would be a parameter because different cars would have different maximum.
That's exactly right. Yeah, my Honda Fit's going to have a smaller gas tank than your Toyota Highlander is probably, right? Because that's a big SUV. So that's going to change from car to car. That's an indication that we need to have a parameter for that. Tank size or something, right? So we'll use that to set this instance variable. And then finally, for the current amount of fuel, right? I'm kind of going to make the same argument that I would make for this one. When a car first comes off of the lot, I know how much gas is in it. The tank is empty. There's no gas. Or I would also accept, you know, some people were feeling generous when they took this exam. They set the current amount of fuel to be max fuel. The tank was full. I'm okay with that. I don't have a problem with that either, right? But the idea is that this is another constant value that we don't need to accept a parameter for. Are there any questions about how this constructor works? Because I believe it's finished. I believe it's complete at this point. Does anybody have any questions, confused about what I did? Okay. Then let's go ahead and take a look at the methods that come down here, right? Let's start actually with this simple one, get miles driven. That's a very easy one. In fact, this is an example of a certain type of method. I know we usually call them getters, but another term we used was accessor method, which includes both getters and setters. So this one is pretty straightforwardly just going to return the amount of miles that have been driven. It's a very quick one. Anytime you see a method that starts with the word get, well, I don't want to say anytime. There are always exceptions, but a large chunk of the time, methods that start with the word get are going to be very straightforward like this. Very simple one-liners. Now let's talk about this one. This one's a bit more complicated. We're going to drive this car. And so we're saying that this is how fast we were going, and this is how long we were driving. And so we have to think, okay, how do we account for the effects of driving the car on these instance variables? When I drive the car, the number of miles driven is going to go up, right? The miles per gallon isn't going to change. The max fuel isn't going to change. The size of the gas tank isn't going to change, right? Those are steady. But the amount of fuel that I have is going to go down because it takes gas for me to drive. In fact, that's kind of an interesting little bit of a wrinkle. Do we have enough gas to drive this far? Right? We're saying we're going to drive this far, but do we actually have enough? It says or until out of fuel. So there's two paths that this method has to take. One is we have enough gas to drive this far, and the other one is we don't have enough gas to drive this far, in which case we're just going to drive as far as we can. We're going to run it on empty, and then you have to call your mom to come pick you up or whatever, right? So let's start with the case where we do have enough gas. We actually need to check for that first. So how far are we trying to drive? We're trying to drive miles per hour times the number of hours. So if I drive, 10 miles an hour for an hour, that's going to be 10 miles, right? How much gas is required? That's our next question that we need to figure out. That's going to be based on the miles per gallon. So if I've driven 10 miles and I get 10 miles to the gallon, that's going to take 1 gallon of gas. So that's a division, I believe. And now we can finally ask ourselves the question, do I have enough gas to get where I'm going? So, all right, if the gas required is less than or equal to the amount of current fuel that we have, this means we have enough gas. And then I'll stick an else down here that we're going to have to visit eventually. It says not enough gas. If we have enough gas, I think our next step forward is pretty simple. We need to update how many miles we've driven, and we need to, oh, this is actually kind of a bad variable name, huh? I don't know if any of you noticed that, but I named this variable exactly the same as one of my instance variables. That's not technically wrong, but it is kind of confusing, I would argue. So if that makes you uncomfortable, as it does make me kind of uncomfortable to have these two, I would encourage you to come up with a different name for this instance variable. So I might change it to attempted miles or something like that, just so there's no confusion between the two. All right, so we just need to figure out if we have enough gas, then we just need to take out the gas, right? Subtract that from our current fuel and add on the amount of miles that we've driven to here. So those should be pretty straightforward statements. Now, this situation down here, where we don't have enough gas, requires a little bit more work. And if I'm being entirely honest with you, in writing this exam today, I probably would have written the question to leave this part off, because I think it's just a little bit too much to ask in this particular problem. Not that you can't do it, it's just, we get the point already. But let's go ahead and finish it for completeness sake. We need to figure out how far we can go with the amount of fuel that we actually have. So we can get that by creating a variable to compute the miles per gallon times the current amount of gallons that we have. So if I have 10 gallons in the tank and I get 10 miles to the gallon, then that should get me 100 miles that I can go. And and then we'll go ahead and update, you know, our odometer. And then our gas tank, in this case, would be empty. We used it all. Bit of a complicated one, this part of the problem. Not going to deny it, but the important thing to keep in mind with this problem, or any problem, right, is this hint right here. How does driving affect all of these instance variables? Sometimes it might require me to change these values, other times it may not. Consider for each of these instance variables what's required. For adding fuel, that's the last one, I believe. Yeah, adding fuel is the last piece of this particular problem. It accepts how much fuel we're trying to add, but it says as long as it does not exceed the tank's capacity. So there might already be gas in there. We're trying to put more gas in there. We need to make sure we don't overfill. So we need to check for that first. We need to say if the amount of gas that we have plus the amount we're trying to add is greater than the maximum amount of fuel that's allowed, that means that we're going to fill the tank, right? Fill the tank to capacity, and we might have some left over. Might have some gas left over. So filling the tank, that's our first statement. We can do that by simply saying that the max fuel is going to be equal to, the current amount of fuel is equal to the maximum amount of fuel. That will fill the tank. Down here, actually I think we kind of need to do the same thing, don't we? Or no, not max fuel, we need to just add. If I'm not going to fill the tank, then it's as simple as, oh my gosh, I cannot spell all of a sudden. Adding the gallons into the tank. Eclipse is mad at me though. Does anybody know why Eclipse is mad at me? I didn't do a thing. I need to return something. I told you that the return type was double right here. I have to return a double. It's not optional. It's required. And so it says that I should be returning the amount of fuel that couldn't be added. So if there's extra fuel, right? If there's only room for 2 gallons in my tank and I try to put in 10 gallons, then I'm going to give you back the extra 8. So let's think about that for a second. How much extra fuel do we have? Well, we can compute that. It's going to be based on the amount of empty space in the tank. So the number of gallons minus the maximum fuel minus the current fuel. Is that right? This is how much empty space there is in the tank. This is how much we're trying to put in. For the case down here, where all of the gas fits in the tank, we don't have any extra, so the return is just going to be 0. There's no extra gas at all. It all fits in the tank. All right, I think we've completed all of the parts of this problem. I'm glad you asked me to do this one. I think this is a great review of how to do basic object class design. Question?
Yeah, so when you were doing the extra fuel just now,
Yeah.
why did you do gallons minus this dot max fuel minus current fuel instead of like this dot current fuel?
Did I make a mistake? Something didn't feel right when I was typing this out. Did I make a math mistake here? It's very possible that I did.
I just meant like more why we didn't do this.
Oh, why I
dot
didn't
or-
do this? That's just me going faster than my brain. Yeah, my brain going faster than my fingers. Yep. It's also not required though, and I'm glad you asked that question, right? It's not required to put this dot out in front of instance variables, but it can be required if you have multiple variables with the same name, which I actually did earlier, right? And that could have gotten me into trouble. So on the exam, don't feel like you're going to get taken off if you don't put this dot out in front of your instance variable. That's not true, unless I can't tell what you're talking about. If I can't tell which variable you're talking about, then yeah, I'm probably going to take points off of that. Good questions. Any other questions about this problem before we can do another one? Yeah, did you have a question? About this problem? Yeah. Can you say that for me one more time? I didn't quite. Math.min? Yeah, you sure could. Yeah. Absolutely. There's probably a lot of different ways you could accomplish this. Yeah, this is not the definitive solution. It is a solution. Yeah. Any solution you come up with on an exam that gets the job done is a-okay. Any other questions on this problem before we take a look at some different ones? Does anybody have a problem they would like for me to talk about or go through, or any questions? Or, yeah.
Actually, I have a question.
Yeah.
I said, like, I know it asks specifically for 4 instance variables here.
Uh-huh.
But, like, practically, like, a lot of the other variables that we created in these methods, couldn't those also be instance variables, or no? Like, why do we choose
Like these?
Yeah, like, why do we choose which ones to make instance variables and which ones
Okay,
not?
sure, yeah. So the question is, could these be instance variables? I mean, the answer from a technical standpoint is yes, absolutely. You can create as many instance variables as you want. So if you really wanted to make these as instance variables, there's nothing stopping you. However, I think you're kind of trying to get at the real reasoning behind it, which is like, why do we make some of these here? Why do we make some of these up here? What's kind of the difference? Consider, am I ever going to need this variable outside of this method? That's really the main question I'm asking, right? If I need this right here inside of this block of code and I never need it again, then that's exactly where it needs to be. And if I use something across multiple different methods, you can see, right, current fuel gets used across many different methods. That's an indication of an instance variable. But I would also like to remind you of that has a relationship, right? Some of these I feel like don't really work. Car has a gas required. I mean, that sounds a little clunky to me. It doesn't quite fit as an instance variable. Yeah, great question though. Yeah. Any other questions on this one before we hop to a different problem? I didn't see any suggestions for another problem, so I'm going to show you a problem that I kind of coded up a little bit before class that deals with inheritance. I wanted to make sure to do an inheritance problem with you today, since that will absolutely be on the exam. And so we're going to talk about schools and universities. In fact, this kind of builds off of the assignment that you were asked to do for assignment 7, making students and courses. This is not in the repository. This is a little extra bonus one that I came up with just to kind of work on as practice today for inheritance purposes. So we're actually not doing inheritance just yet. This is going to be our base class. The school is going to be our base class. But I would like to go through it. I think it's a good review of object-oriented design. We also can see there's a list down here, so that's good to get used to that data structure as well. We're going to create a school class. We want to keep track of students who are enrolled at the school. And we're actually going to use the student class just as it exists in the assignment 7. I actually have a copy of that class right here. It's my personal copy of the student class. It doesn't even really matter what that code is. I'm not interested in talking about that code with you right now. But this can do all the stuff that the students could do on assignment 7, and all the methods that were available to you on that assignment are available to us here, which is a good time for me to point out this very important piece of information to you. If I'm asking you to use an object like a list or even student, even though I know you had it on an assignment, right? I will still provide you information on what methods are available, just like I would for the standard draw methods on the PASS exam. I will tell you what methods exist in the list class and the map class and any other classes that you need. It's still your responsibility to use them properly, but you don't have to memorize all the different methods that exist, right? That's not a good use of your brain space. It's not a good use of your sheet of paper either. Don't bother, spending a ton of time on that. It's more important to me that you know how to apply those when you need to and can use the reference to do so properly. That's good programming. So I will give you a sheet at the very back of the exam that has a list of all of the methods on it. And when I give you that list, I want you to think very carefully about the fact that what I'm really saying is you can do everything on the exam with the stuff that it's on this list, right? So you don't need to pull some magic method from out of nowhere to do what I'm asking you to do. It's all doable with what I'm giving you. All right, let's talk about this school class. I gave you the instance variables this time, so no choice here. Told you not to change them. Our school has a name and it has a list of students. So we want to create a constructor, and it's the same question as before. Where are these values coming from? Are we going to accept them as parameters, or are we just going to simply state what it is? And I think this is a great example of one of each of those, right? For the name, every school has a different name. When you create the school, I'm going to need you to tell me what you want the name of that school to be so that I can set that to the instance variable. But for the list of students, we can see here when a school is created, there should be no students enrolled. It's a brand new school. Nobody's signed up yet, right? So that doesn't mean that we're off the hook here. We still have to do something with this. This is still an instance variable. There should be no students enrolled. This list needs to exist. It just needs to be empty. A lot of people forget this part, right? A lot of people forget this part. If you see a list as one of your instance variables, at the very least, you need to call the constructor to create that list. Remember, this list is an object. This object does not exist until the constructor is called to create an instance of it. So if you need that list, either it's got to come in as a parameter, or you need to call the constructor yourself. And I'm making the argument that since we just need an empty list, calling the constructor ourselves is the appropriate thing to do here. And it would look something like this. I need to import to make this work. You don't need to worry about imports on the, please don't worry about imports on the exam. Not something you need to be concerned with. This constructor does satisfy the goal, though, of making sure each of these instance variables have an appropriate value, right? This is set to the parameter, and this one is set to a very empty list. This is the one that students forget most often, so I want to make extra sure that you understand what's going on here and why. Let me know. Yeah.
Explain that last line.
This line right here that's highlighted? Yeah, so this is like, I might be able to explain a little bit easier by, let's take the instance variable piece out of it for a second. If I wanted to, I could declare, students as just a regular variable like this. And he's probably mad at me because, here we go. If I was just going to create a list normally, right, I wouldn't do it like this. I would do it like this, right? That's how we've created linked lists before. This is probably more common to what we've seen it all on one line. The difference between this and what I'm asking you to consider now is that, well, this is just being moved up here to the instance variable slot, but we still need to do this half. You can't forget about that half. That's not going anywhere. We're just going to do it on the instance variable instead of doing it all in one line. So both halves still exist, it's just the declaration part got moved up to the instance variables, and calling the constructor still happens down here. I hope that was a little bit better of an explanation, but please let me know if you have any other questions. Are we ready to move on? Not seeing any hands, so let's go ahead and move on. These next ones, so it says returns true if the given student is on the list of enrolled students. So we're just asking the question, is this student enrolled? And so here's the time where you need to, refer to the methods that exist in the list class. Again, I will give these to you. You will have these on the back page of the exam. Not all of them, because you won't need all of them. And there's a lot. And I wouldn't expect you to know how all of these work anyway. I don't even know how all of these work, right? But the common ones, I definitely would expect you to know how to use. And oh, hey, look, there's a method right here called contains that seems like it could be very easy, very useful for us. One thing that I saw a lot of students try to do on this one, which I think would also work, it's just not necessary, is they would write a loop to go through the list and check each student one at a time. That's extra work. You can do that, but definitely going to be much faster for you to do something like return this.students.contains s. Or you can even take the this dot off if you want to, right? We already talked about that, why that's allowed. This will get the job done much more directly. This one first checks to make sure that the student is not enrolled before adding them to the list of enrolled students. So we don't want to have the same student on that list more than once. That was a property of lists that we actually talked about. Lists can contain duplicate values. But in this situation, we don't like that. We don't want the same student to appear multiple times on my list of enrolled students. That's not going to help us at all. It would make things confusing. So, we can check. We could say if, and you could say students.contains here again if you wanted to, or you could say is enrolled. You could use the method directly. Actually, we would want to check to make sure the student is not enrolled, right? If the student is not enrolled, then we need to get this student onto the list. Well, refer to your list of methods. The add method is the one that we're going to need here. We can just say students.add s. So a little bit more than was required of us from the last one, just because we had to do that extra check. But notice that a lot of these methods are really just referring to methods that already exist as part of the list, right? The methods are just manipulating the list in various ways by adding students or checking to see if students exist on the list. Here we go, remove. May not surprise you, is going to follow a similar format. In fact, if I scroll down here, I'll see, oh, hey, look, there's a remove method right here that does exactly what we need to do. That's it. That's that one. Not a trick. Nothing fancy required. Don't overcomplicate things. If it seems simple, that's a good thing. I like simple. I try to ask you questions that have somewhat simple answers. So don't think I'm going to intentionally ask you something super tricky. Are there any questions about this class before we talk about inheritance? Because we're about to do some inheritance with the next one. Okay. Let's switch and talk about the university class. So a university is a school. So there's that is a relationship. University is a school. So we've already established the inheritance by putting the extends keyword in there. That was already given to us. Right? So now we just have to think about what makes a university unique from a school. The problem says that the main difference is that universities have the ability to grant degrees, and they want to keep track of how many degrees have been granted. So they want to know how many degrees they're handing out. Your university class should include an instance variable to track how many degrees have been granted by the institution. Okay? So let's go ahead and start with that. Put our instance variable here. We want to track how many degrees have been given out. That's going to be an integer, right? You don't deal in fractions of degrees. That's not a thing. Now we have to call the constructor. We're using inheritance here. So this constructor is responsible for making sure that these instance variables get set, but also making sure that the instance variables from the base class get set. And the way that they primarily do that is by calling the constructor from the base class to handle these instance variables, and then dealing with any other instance variables afterwards. How do I refer back to the base class? How do I call the base class constructor here? Anybody remember? That's where the super keyword's going to come in. But I'm calling the constructor, so if the constructor has parameters, I have to include the parameters here as well. I have to include these parameters here as well. So this one has a parameter called name. I have to make sure that I pass in that name when I call the constructor. So where does that come from? Well, chances are if it was a parameter to the base class constructor, it's going to be a parameter to the derived class constructor as well. And that way I can take this from here and just pass it along directly to the constructor for the superclass. So that takes care of setting the name instance variable. It also takes care of setting the student's instance variable, because the school constructor takes care of that here, right? Even though we don't see that, that's all handled for us. Now we just have to figure out how to take care of this one, and it says when a university is first created, the number of degrees it has granted is 0. So that seems like it should be pretty straightforward. Degrees granted equals 0. Any questions about how I handle the constructor? Yeah. More of a what question? No, go ahead. Go ahead.
When we're doing lists and hash maps, you were declaring when you say list, private list,
Mhm.
and then list, but then when you're setting it, you say that it's either a linked list
Correct.
or we say hash map.
Mhm.
But we learned about all the different types of lists.
Mhm.
But we didn't just learn about linked lists. We expect to have different things, whether it's a linked list or an array list or whatever.
So I agree with you. We did talk about different types of lists. We talked about linked lists and array lists being different types of lists. We didn't really talk about what those differences are, though, or when you should use an array list versus a linked list. We didn't talk about that at all. There are situations in which you should probably choose one over the other, but that's actually not really a question for this class. That's a question for your data structures class, 247, that a lot of students take after this one. So in terms of the exam, in terms of what I'm hoping you get out of this course, I don't care if you use array list or linked list here. You can actually even do this if you really want to. I think it's less correct, but still correct. I wouldn't take points off for it or anything if it's really concerning you, if it's really bothering you. But this is definitely the preferred style. This is how professional programmers would do it if you're getting paid money, right? That's how it's expected to be done. What goes here for the exam? Pick one, roll with it. What I'm more concerned about is, can you drive the list, right? Can you call get? Can you call add on the list to manipulate the items in the list? Whether it's a linked list or an array list, I don't care. I hope that answers your question. Yeah, awesome. So getting back to this one, down here we see that there's a method called graduate. So if the student is enrolled, we don't want to graduate a student who doesn't even go here, right? That would be kind of silly. So if the student is enrolled and has more than 120 credits, that's something we have to ask the student about, right? The student knows how many credits they have. Then we're going to remove the student from the list of enrolled students, and we're going to grant them a degree by bumping up our degree counter. So there's a few checks we have to do here. We have to say if the student is enrolled. I think using our method here is really actually the only way that we can do this, because if I try to do students.contains here, it's going to be upset with me. Why? Why can't I do this here? we inherited the student list from the school, so it definitely exists. It's just not happy that we're using it this way. The problem isn't that it can't find this. It knows that this list is here. It knows that the list exists. It knows that the list is a thing. It just is unhappy that we're doing things this way. Why? It has to do with how things are declared. This list is declared private. That means we cannot use it outside of this file right here. Doesn't matter if we're using inheritance. It's still not allowed. Still not allowed for us to do. So there's a few ways that you can get around that if you run into that situation. One is to use getters and setters. I could have given you a getter for the list and let you access the list that way, but I didn't. I didn't give that to you, right? I didn't ask you to provide one. So what's the other thing? Well, use the other methods. Use the other methods that exist. And so, yeah, you can see that we have a method for isEnrolled. We have a method for removing students, right? Those are what we need to do in this problem. So we're just going to use those methods. I'll say if isEnrolled s. So if the student is enrolled, and we need to make sure that the student has enough credits. So s dot what? Get total passing credits, right? Greater than, is it greater than or equal to? Greater than or equal to 120? If we know that's the case, then we can remove the student. Also, I think it should be pointed out that I could say this dot remove. That's totally fine. Either way. For the same reason as the instance variables are allowed to use this or not use this. It's the same reason. Same reason. And then we need to increment the number of degrees granted by 1. I believe that's going to take care of that method. The last one that we have here is the toString method, which remember is kind of a special one. The toString method is one that has a little, associated thing with it where if I print out an object, this automatically gets called. So we're specifying what a university should look like if it ever gets printed out here, essentially. And we're telling you that it should contain the name of the university as well as the number of degrees that it is granted. So, the simplest way you could do that is to just return this dot name plus this dot degrees granted. That's not going to look very nice. Actually, we can't do that because this is the same thing. This is a private instance variable. I believe I did give you a getter for this one, though, right? That one's a little sneaky. That one is a little sneaky, I do admit. So this will get the job done. This would have gotten full credit. It's not going to look good. It'll all be smashed together. I don't care, right? It's an exam. Not worried about the formatting for this one. If you want to put some spacing in or something to make it look a little nicer, that's, of course, just fine. But this is the absolute bare minimum that you would need to put down to take care of this problem. Are there any questions about this one? Yeah, in the back. Yeah, in fact, I might be able to show you kind of what the page looks like a little bit. If I can find a good copy of it. Let me show you last semester's. The very last page looks something like this. So below are shortened versions of the Java doc for methods found in list. And I'm telling you that you can do everything you need to do on the exam with these methods. And then here's the ones for student. I included these because you have to use the student object on that problem that we just did. So here's the list of methods that are available in that class. If I ask you to use maps, which is definitely a thing that could happen, then I would expect to see methods relating to maps here so that you have access to those on the exam as well. But yeah, we'll provide you this. It's not a complete, it's not the whole web page, right? That's not necessary. It would be too much. We give you what you need. Give you what you need. Any other questions about this problem before we move on to another one? Does anybody have another problem they'd like to see me do? Be happy to take, yeah, please. Can I do one about maps? Probably. I'm trying to think of, I believe this dormitory one actually. Yeah, this dormitory one uses maps. So let's take a look at this one. All right. I already gave you the instance variables down here, but it's, you know, useful to take a look at the problem description anyway, make sure we understand what we're working with. It says a dormitory has a mapping of room numbers to students. So how are maps structured? For lists, we have an index. For arrays, we also have an index, right? But for maps, we don't have an index. What do we have for maps? How's the data stored within a map? Key value pairs. Key value pairs. I like to describe it as, you know, create your own index, right? If we use the list or an array, our index is 0, 1, 2, 3, 4, so on and so forth. But for a map, we get to make up our own index. And it can be literally anything. It can be literally anything. So here we're using strings, where the strings would be room numbers, right? So the string is quite literally what room you're assigned to, and the value is going to be the student that is assigned to that room. We're kind of making the assumption that everybody here gets their own single room, which I know is not entirely accurate, but I didn't want to make this any more complicated by allowing roommates into the mix. If you just as a little side note though, if you wanted to make roommates, totally doable. Here's something for you to think about. I can do this. I can make the value not just one student, but a list of students, and that way I can have a whole list of students associated with one key, with one room. But that's not what I asked for. We're assuming that every student gets their own individual room for this problem. So you can see the map's been, the instance variables have been set up for you. We do have to do the constructor, and it says, yeah, for full credit, constructor should use only one parameter. So we're going to create the dormitory constructor. All right, gave you a pretty big hint here with that one parameter. Which one? I mean, probably pretty obvious based on the last problem that we did. Which one's going to be coming in from the parameter, and which one won't? This one will be coming in as the parameter. We'll set the name accordingly. The hash map, just like we talked about in the school with the list of students, this is an object. Hash map is an object. This is just the declaration part. This is just the first half. We still need to do the second half, which is setting up the instance variable by calling the constructor. So this dot rooms would be equal to new hash map, like so. Everybody with me so far? Any questions about what I did with the constructor? Okay. All right, start off with a very simple one. This is another getter, another accessor, so this one should not be too tricky. We're just going to plug in this.name. The amount of rooms that are currently occupied. So this might seem like a little bit of a trick with if you focus too much on the currently occupied part of it, but if a room's not occupied, it's not going to be in the map. I'm just quite literally asking you, how big is the map? How many entries are in the map? If a room is empty, then it just won't show up. So, you know, how do I get the number of things out of a map? Well, you'll have your reference sheet on the exam that has a portion of these methods on there, and I guarantee one of the ones that will be on there will be size. Turns the number of key value mappings in this map. So for the number of rooms that are currently occupied, I need to access my map, this.rooms.size. All good? Everybody with me? All right. Now we're going to add a student. So I'm gonna, assign a student to their room in the dorm. And I need to make sure that that is taken, recorded in the map. So you can see that I'm telling you what room number this particular student is going to be put into. How do I get stuff into a map? It's not the same as a list. It's not the same as an array either. It's a different kind of data structure. But you will have this reference, I hope, from the practice in class and in Studio. You'll remember that there's a put method. So that is how we assign keys to values with a map. It's by using the put method. That's exactly what we need to do here. I would say this.rooms.put. And Eclipse is very, very wise, has already detected exactly what I'm trying to do here, filled those values in for me. That's it. Notice, just like the last one, that while these methods are not going to be overly complicated, going to map directly to methods from the data structure, the underlying data structure. I believe this is another example of that method, right? It says of that kind of a method. It says returns true if this room contains a student, false otherwise. So I'm not even asking what student is in this room. I just want to know if there's a student in this room. Is this room occupied? What do I find in a map if I plug in a key and there's no value with it? What's the map going to tell me? Null. So that's actually one way that you can solve this. It's not the only way, but one way you could approach this is to say rooms. How do I retrieve values out of a map? Oh, refer to your sheet. Recall that we use the get method to plug in a key and retrieve the value. So I'll say rooms.get room number. If this is not occupied, then this would be equal to null. If it is occupied, then it would be not equal to null. That's one way to do it. That is one way to do it. That's not the only way to do it. You may also be referring to your list of methods that are available on the map and come across this one called contains key. Is this key in the map? Does this room number exist in my map? If it's not in my map, then nobody's in that room, right? So that's another way you could approach this problem. You could simply say return rooms.contains key room number. I like this answer as well. They're both fine, both okay. This last one does require a bit of effort, because you can see that we're actually going to be returning a list here of all of the student IDs for everybody that is staying in this dorm. Now what that requires us to do is check to see who's staying in each and every room of the dormitory, grab that thing back out, and ask them for their student ID. Let's break this down into chunks. We need a list of student IDs. That list does not currently exist. So the first thing that we need to do is make this linked list. List of integers, we'll call it IDs. I'll make it a linked list. So this is just a brand new empty list for us to use. Are you just unhappy about imports? Yeah, not worried about the imports. We now need to iterate through and visit each and every thing in the hash map. However, that's actually a little bit complicated. Recall that hash maps are not stored in any sorted order. I can't just say for int I equals 0, I less than so-and-so, I plus plus, because there is no index 0 in a hash map, right? That's kind of the whole point of maps, is to not follow that 0, 1, 2, 3 indexing order. So how can I make sure that I visit everything out of a map? It's actually somewhat tricky. And I did give you an example of this in the exam, in the exercises batch 3. If you want to refer back to this, take a look at the, take a look at this. Take a look at this example, keys from module 9. Shows you how to write a loop to go through the key set So I'm actually just going to copy that code directly and switch this to say rooms, since that's the name of our map, not phone book. So this is going to write a for each loop where this should be room number, right? Where this is going to take on the value of each key that exists in the map. So the first iteration through the loop, it'll be one key. The next iteration through the loop, it'll be the next key, so on and so forth. I can grab the student out by plugging that key into the map. So I would say rooms.get room number. And then what I ultimately need is the ID from that student. And I need to take that ID and stick it into this list. So IDs.add, that's how I add something to a linked list, not a map, s.getID. Once we're all finished, don't forget to return the completed list. What are you unhappy about? Oh, really? It wants this to say linked list? This should really say list, actually. That's more correct. That's a my mistake, though, not a thing that you need to be concerned with. Definitely the most complicated problem of the two requires you to use a list and a map. Extract items out of a map, stick them into a list. So definitely the most complicated one on this particular problem. Does anybody have any questions about this one? Okay, let's do these down here because we actually haven't done this part yet. We haven't called too many constructors yet today. And this is another area that I find students kind of tend to struggle on a bit. Remember that a class is really just a template. A class by itself is an abstract concept. It does not exist. It just says how to make something and how that thing should behave once it does exist. So in order to use a class, we have to call the constructor to create an instance of that class. And once we have done that, we can call methods upon that class. So what these questions are asking us to do down here is exactly that. It says create an instance of the dormitory class and store it in a variable called dorm. So, okay, I'm going to create a dormitory variable called dorm. That means I have to call the constructor. So when I call the constructor, I'm going to say new dormitory. And then I have to plug in a name. I didn't tell you what the name should be. I expected students would just type in the names of the dorms that they're in. I didn't go here, but I lived in Forest Hall when I was in a dorm many years ago. Oh, and I misspelled dormitory. There we go. So this is going to create an instance of the dormitory class and store it in a variable called dorm. Create an instance of student and add that to the dorm. So I'll say student s equals new student. What's the constructor? On the exam, this would be given to you as part of the reference sheet, but since we don't have that, we can see, oh, this is actually just a very basic one that just takes the ID in. So I can just say 7 here. And then how do I add this student to this dorm? Well, I wish to use the add student method of the dormitory class. I have to call this upon an instance. So I'll say dorm.addStudent s. Whoops. I need to give it a room number, right? Again, I didn't tell you what the room number was, but you can just make one up. I don't care what the room number is, just make one up. And now, this one, write code to determine if a student with the ID of 1, 2, 3, 4, 5, 6 is in your dorm using the appropriate methods. So think about what we have to do to make that happen. I have to get the list of student IDs, and then I have to see if the ID that I want is on that list. So really two kind of steps that we need to take. So I would say something like dorm.getStudentIDs. And if you wanted to, you could actually do this all in one line. You could say dot contains 1, 2, 3, 4, 5, 6 and call it a day. We haven't talked about chaining stuff together like this a whole lot, so if you wanted to break it up into 2 lines, which I think is probably a more common way to approach it, you would say something like this to store the list of IDs in a variable, and then say IDs dot contains on the next line to check to see. These kinds of questions will absolutely be on the exam, 100%. I always like to ask questions like these. Just trying to see if you all understand the difference between, creating the class, the template, versus actually using the template, creating instances, and applying methods to the instances that have been created. Those are 2 kind of separate things. Does anybody have any questions for me about any of these problems? I think I may have time to do a quick one. We've got a little less than 15 minutes left, I believe. If anybody's got a quick one they'd like for me to go through, maybe a code reading problem, or I might pick a code reading problem actually, if I can find a good one. Yeah, let's do this. Let's do this bike one to wrap up the day today. This is a code reading problem of the style that I kind of went through during the last class. If you remember me drawing the diagram with the circles and the arrows and the references, one of those problems was absolutely going to be on the exam. I promise you. So I give you a class. This is a class called Bike that does, bike-like things. And down here, there's a main method. There's that word static. I told you it might appear once or twice if there's a main method, but no static otherwise. So I'm asking, what is this going to print? What is this going to print? You need to be able to go through this line by line and make that determination. So here's the first print statement. Let's see if we can work our way through. And I'm actually going to show you how I would work this out on paper, because I think it's very important to follow the process, understand exactly what's happening here. When I see a line like this, especially the right half, this is calling a constructor. This is making a new instance. Before this line ran, we had 0 bikes, no bikes at all. After this line exists, we have 1 bike, right? So, I'm going to make a diagram to represent that fact by drawing. I usually draw a circle to represent my instances. And then I'll put my instance variables inside of that. So, what is the instance variables? The maximum gear is 10. The current gear is 1. So inside of here, I would say max is 10. Current is 1. All right, but that actually just takes care of half of the line. Calling the constructor creates the instance. The left half of the line creates a reference to that instance. So this is creating a label called 10 speed that points to that thing that I just made. And that is a very, very important concept to understand. I represent that in my diagrams by drawing that arrow. Right? So I draw that arrow pointing at this instance, and then I label it 10 speed. Sorry for my bad MS Paint skills. I did all of that. All of this got added to my diagram just as a result of this line. All of it. And a similar thing is going to happen here, right? I'm making a second bike. So before this line executed, I had 1 bike. Now after this line executes, I'm going to have 2 instances of bikes. I'm going to have 2 distinctly separate bikes. It's going to look very similar to the first bike that I created, except this one has 18 speeds for its max. But like all bikes, it starts out at 1. And the label for it is not 10 speed, but 18 speed. Something like that. Okay, so now after I've executed the first 2 lines, this is what my diagram looks like. I haven't even gotten to a print statement yet, but we're going to do that now. 10 speed dot shift up. So it says if the current gear is less than the max gear, which it is, 1 is less than 10, then I'm going to add 1 to that, so that's going to bump it up to 2, which I would even come to my diagram and reflect right away. Cross that out, and now stick a 2 here. I'd probably use an eraser if I had one, but this is MS Paint, so I'm doing the best I can. And then it returns current gear. That's what's going to get printed. So the first thing that I'm going to see get printed right here should be 2. Everybody with me on that? Everybody see how the 2 pops out? We then call the pedal method. So let's take a look and see what happens here. It says, oh, we need to shift up, which is going to bump the current gear up again. So now the current gear is going to be 3, and I'll reflect that in my diagram. Right? Make sure I have that reflected. Current gear is now 3. And it is going to print out the current gear again. So this would print out 3. I can actually run this and show you what it would print out. Hopefully the first 2 numbers are 2 and 3, otherwise I'm way off base. There we go, 2 and 3. Perfect. All right, this one says for 10 iterations, we're going to shift this guy up. Shifting up doesn't print anything, so we're really just shifting this up 10 times. That should make this be 11 after we go through this loop, right? This guy's going to be not 1, but 11. 1 plus 10. But then, on the very next line, we say 18 speed dot pedal. That's going to shift it up 1 more time. We're now on 12. And that's what's going to get printed out, which we can confirm by seeing that the next value is 12. So when we get here, we'll see that's going to be 12. And the diagram should also be updated to reflect that as well. All right. We're almost to the more interesting part. We're going to do a shift down. So shift down says we're just going to subtract the number of gears off and return the current gear. I'm taking 5 gears off of 3. I don't have that many to take off, right? So what is it going to say to do instead? Well, it's just going to set it to be 1. All right, that makes sense to me. So this should give us the 1. And if I look down here, I'll see there's the 1. That's good. We would update our diagram as well to reflect being on first gear. And this line right here, it might look like I'm creating a new bike if I look at the left-hand side, but I don't see the new keyword here. I'm not calling the constructor, right? So this is not creating a new bike. I have 2 bikes before this line. I will have 2 bikes after this line as well. What I'm creating here is another reference. I'm creating another arrow. So I'm not making a new bike. That's what calling the constructor does. That's when I add the circles. I'm making a new reference. I'm saying that I want another arrow pointing at this bike called Huffy. So I would make an arrow up here pointing to this same one, right? And now I have 2 references to the same instance. This is where things maybe get a little bit confusing. I would encourage you to remember that we do this as humans all the time, right? You all call me Professor Shook. I go home. They don't call me that. They call me Dad. They call me Doug. Dad refers to me. Professor Shook also refers to me. I'm the same instance. I'm the one guy, but both of those labels refer to me, depending on context. So that's really what we're illustrating here as well, is that we can do that in our code. And so what does that mean? When I say Huffy.pedal, what's going to happen? It's going to shift up the Huffy by 1. It's going to make this 13, but pay attention to the fact that, well, shifting the Huffy up by 1 is the same thing as shifting the 18 speed up by 1. They are the same bike. They are one and the same. If I shift the Huffy up 1, I'm also shifting the 18 speed up 1. So this is another area where students will get tripped up a lot on this one. After we make this assignment, this changes both of them. And then we go ahead and make things just absolutely silly with this line. We say that 10 speed is equal to Huffy. So what is that going to do? That actually has the effect of erasing this thing altogether. Drawing a third arrow over here and saying that this is now 10 speed. Think about what that means for a second. There's no more arrows pointing to this guy on the left. It's abandoned. Quite literally, we call that garbage in computer science. That object is now garbage. That is the official term for it. Not joking. It is garbage. If there's nothing pointing to it, it's trash. We can't get to it anymore. Over here on the other side, we now have 3 references pointing to the same bike. 3 references pointing to the same bike. It might seem silly. It might seem inaccurate. How can I have 10 speed and 18 speed both pointing to the same bike? Computer doesn't know what that means. Computer does not care. Is it a little bit confusing? Yeah. Is it valid code? Also, yeah. Also, yes. We can absolutely do this. And so what does that mean? That means that after this point, any changes that I make to Huffy, 10 speed, or 18 speed are all changing the exact same bike. Or another way to think about it is that these numbers are never going to change again. These numbers are only going to change unless or until I make another bike or a new reference or change the code in some other way. All right, we've covered a lot of ground today. I think this is probably as good of a stopping point as any. Please let me know if you have any other questions. I'll be around in the labs later on this week, and I'll see you at the exam on Thursday evening. Have a good week, everyone.